can be asked in a number of different ways. But the idea is that it's probability, so therefore all the options basically add up to 1. This is saying to you, you've got a random variable k, the probability that k is, and it gives you a formula, and that gives you values for k. It's 0, 1, 2, 3, or 4. So that 0 elsewhere means that the probability is 0 everywhere else. This is the only thing that exists. When k is 0, 1, 2, 3, or 4. So if we're asking to find the value of m, we can substitute all these values in for k, but we can make an equation by making it equal to 1, and that way we can solve for m. So m comes out to be 1 over 30, and we can actually answer any questions. So they could ask you, let's say, find the probability that k is less than 3 would be 0, 1, or 2. So I would now go 0 or 1 or 2, and I would get the probability of that happening. Okay, what is more likely to ask is, let's say they give us some kind of a situation. So this is, Andy has 4 red socks and 8 black socks in his drawer. He takes 2 socks at random from his drawer. Find the probability that the socks taken are of different colors. So I see this as hypergeometric, which you could do as hypergeometric. So the idea is he's taking 1 red sock and 1 black sock, but the 12 choose 2 is what. So my solution for that would be, I just chuck that into my calculator. Okay. The random variable x, they say, is the number of red socks taken. Draw up a probability distribution table for x. All right, so now it's getting a little bit more real. So the probability distribution table has got your random variable at the top, all right, and then all the possible options. So what could you have got? This is my 0, means I could have got no red socks. 1 means I could have got 1 red sock, and 2 means I could have got 2 red socks. Okay, so my probability that x equals 0, in other words, I get 0 red socks, would be, I would chuck it into this formula. So that would have been 0 red to black, but I'm still choosing 12C2. So that's 14 over 33. And then likewise, 1 is if I would, well, that would be that solution over there. And if I subbed in 2, it would be 4 choose 2 times 8 choose 0 times 12 choose 2. And that will give me these 3 probabilities. Okay. Question C now says find the expected value of x and the variance of x. So we need that table back for that. So there's my table. The expected value of x is easy to work out. It's simply going to be that number times that plus that value times by that, the probability, plus that number 2 times by 3 over 33. So this, sorry, should have a plus sign in the middle there. Okay, so my probability comes out to be, well, my expected value of x, which is my mean, is 22 over 33. Right, now the variance is a bit more difficult, and I'm actually going to use this mean to be able to do it. The variance is going to be 0 squared times the probability plus 1 squared times the probability plus 2 squared times the probability minus my mean squared. And that is going to be the variance. The standard deviation is obviously the square root of that. Okay, so it's also new to the syllabus, so you can kind of expect this to be asked. Okay, so then the last question here is draw up a probability mass function for the previous distribution. So actually what they're asking you to do is find a formula, all right? And we already know that the formula that we had was, let's just go back to it, was hypergeometric, all right? So I know that I can now put in a value of x to get my solution, okay? So if we just go forward to it, so the probability that x equals x, and I'm going to write it as a probability mass function, would be 4 combination x times by 8, and then what's left over, 12 choose 2, and my x is an element of either 0 or 1 or 2, and then I've got to put 0 elsewhere in. So that's writing the formula for probability mass function. Okay, so you can get a probability distribution table or you can write it as a probability mass function, in which chances are you're going to either be using a hypergeometric or a binomial formula. Okay, then a probability density function basically is pretty easy. The density function is the idea, though, that it's continuous data, which means that we're looking for sort of an area under the curve for the probability rather than 1 plus 2 plus 3 plus 4. So in this case here, they're telling us, again, that the density function, that from 20 to 28 basically adds up to 0. I mean to 1, all right, because probability adds up to 1. So we can set up an integral and we can go, cool, okay, 28 to 20, okay, x to the minus 2 dx is equal to 1. And then I can solve, I can find my integral and I can substitute my values in and solve for k. All right, so in this case here, I'm going to get that k is equal to 70. A little bit of arithmetic, but I think everyone should be able to cope with that. So now that you've got k is equal to 70, you can carry on with the questions. So this question, if they ask you for the median of x, all right, so the median means that basically I can start at 20, but I'm looking for not the halfway point, so it's not 24. The median cuts the area in half. So I'm looking for the area under the curve to be a half, basically, because I know that the full area is 1. So therefore, I can say, okay, cool, my lower boundary, or even my upper boundary, and put an m down here. But 20 to m would be, and I've now used my 70 for my derivative here, I mean for my function, and that equals a half. Okay, and now I can do my integral. I've got my whatever it is. Here it is over there. So I'm looking at my m, and I'm going to solve for m. And I get what m is, which is 23.3, whatever the scenario was. Okay, so the probability density function basically is setting up an integral. All right. Okay, this question here is a random variable x has a probability density function, and it gives us a split function graph, so between 1 and 2, and then 2 and 4. Okay, this is asking us to find the value of a. It is a probability density function, so therefore the total must add up to 1, because they've given us it's naught otherwise. So the probability, these are all the possible options. So we would say there, right, between 2 and 1, and you probably want to multiply that out, plus between 4 and 2, and we want to know what our value for a is equal to, and we've said it's equal to 1. So that's our equation. So this we could either chuck into our calculator or just substitute it in. We're looking at 4 and 2, and we can now solve for a by subbing all those different values in. Okay, the next question is just something that is testing your absolute values with it. All right, so basically what is this saying is the probability, the absolute value of x minus 2 is less than 1, means that x minus 2 is between 1 and minus 1. Okay, so actually all it is your integral between 3 and 1, because I'm going to take my 2 to that side on both of these. Right, so basically, what am I looking for? I'm looking for the value between 1 and 3. So between 1 and 2 is a different graph, so therefore I'm going to stick with the 2 and 1, which I've got over here, plus 3 over 2, and I've got my value for a, so I can solve what that is. Okay, I hope that kind of makes sense, but there isn't much to it. You've got to make sure you get these questions right. Whenever you see one in a past paper or in the worksheets that we give you, practice it so that these are easy marks for you. Okay.